Welcome students. So now in this class we will talk about the remaining three techniques of the risk analysis of the projects or the newly set up ventures, and we'll try to understand that what these three techniques are and how these three techniques work to mitigate the risk of the projects or the investment proposals, or how we can assess the risk associated to these proposals in advance, and we can take the appropriate steps to mitigate that risk or to manage that risk. So the next means the fourth technique. I told you in the previous class that we have six techniques for the standalone projects, and first three we have talked about in the previous class. That is the sensitivity analysis, scenario analysis, and the break-even analysis. Now we'll be talking about the fourth technique, that is the Hiller's model. And Hiller model says that largely this model is based upon the cash flows, and this model says that maybe what is the deviation of the cash flows, right? This is normally dependent upon the standard deviation or maybe the variation in the cash flows. And the model says, or as per this model, though the model is very lengthy, but in nutshell we would like to understand it, that this model is based upon the say cash flows and largely upon the standard deviation of the cash flows. So the model says that if the cash flows are totally uncorrelated, right? If the cash flows are totally uncorrelated in itself, in the time series form as well, in the time series as well as in the dispersion forms also, that if it is widely dispersed from the average of the cash flows, it means the standard deviation is very high and the cash flows are uncorrelated. So when in the time series basis, for example, when you talk about the cash flow for the year 1, 2, 3, 4, 5, 6 and 7, right? These are the different years for the cash flows, or maybe you call it as this is the year when we talk about the cash flows for the different time periods. So we can say that the cash flows you have to find out is for the different years, and when we take it for the years, right, say the first year, second year, third year, fourth year, fifth year, sixth year, seventh year, eighth year, ninth year or 10th year, when we take the cash flows, if these cash flows in these years, for example, this is the cash flow, right? If these cash flows are correlated with each other and they are not dispersed from the mean, in that case the deviation, or you call it as the standard deviation in the cash flows, would be low because the cash flows are correlated. But if the cash flows are uncorrelated, right, they are going in the different direction, so what will happen? There will be a high amount of the standard deviation, and as I told you, we signify the risk by way of the different variation measures, and the most important measure is the standard deviation or the variance. So when we talk about the standard deviation of the cash flows, so we look at in two ways. Number one is that we calculate the mean of this say cash flows for the given this number of years, when this cash flow is given to us for the given number of years, and we calculate the mean, and then we try to see that what is the say variance, or you call it as the standard deviation of the cash flows from the mean value. So if the these cash flows are highly uncorrelated, in that case you can say the element of the risk involved in the project is very high. But if these cash flows are correlated or perfectly correlated, right, and the level of dispersion from the mean value of the cash flows is not very high, in that case you can say that the element of risk associated to the project is not very high. So it's a very simple model if you want to see it, though if you want to implement the model it requires other input values also, but largely it is depending upon the two things, that is the mean value of the cash flows and then the standard deviation of the cash flows, or maybe the standard deviation of the you call it as the cash flows, and then finally the standard deviation of the NPV, and finally here also you are taking about the average value of the cash flows and the standard deviation of the cash flows. So if the cash flows are correlated over the period of time and there is no significant difference in that way also, there is no significant difference between the expected values and actual values, then you can say the element of risk associated in the project is not very high. But if the cash flows are not correlated and they are widely dispersed from the expected value to the to the actual value. So what is expected value? You can say expected value can be the value close to the mean. So if it is widely dispersed from the mean, in that case the standard deviation is high, but if it is closer to the mean and if the level of the standard deviation is not very high, so it means the level of risk involved in the project is not very high. So simply you have to look it at the level of the average cash flows and the standard deviation of the cash flows. And if the say average is a certain amount, but if the standard deviation is very high and the cash flows are uncorrelated, you can assume that there is a high amount of the risk in the project. But if it is other way around, that the cash flows are correlated and they are means nearer to the expected value, in that case the level of risk involved in the project is little less. So this is the, say you call it as the Hiller's model, which in the simplest way can be understood on the basis of the standard deviation of the cash flows and the difference between the expected value of the cash flows and the actual value of the cash flows, and the dispersion of the cash flows from the mean value of the cash flows and the individual years of the cash flow. So difference between the average value of the cash flow and the individual years of the cash flow. So that dispersion and the difference in the, or you call it as the distance from the expected value to the say observed value. So these two means differences or distances cause the high amount of the standard deviation, and if the standard deviation is high in the cash flows, so it means in that case the element of risk associated in the projects is high. So what we have to do is we have to try to find out that when we are going for market and demand analysis to minimize the say risk of the cash flows or maybe the variation in the cash flows, so what we can do is when we go for the market and demand analysis, so in that case we'll have to see that we have to try to grow the demand in a very steady manner, that in the first year we will expect that the level of demand should be maybe some number of units, that for example you are going to sell 100 units and 100 units, right? So next year you try to make it as 150 and then 200 or maybe 250, or if you want to keep it static, so keep it static at 250, or next year you can make it as a 300. If your market and demand means for the product grows like this, naturally your cash flows will also grow like this. So there would be element of correlation in the cash flows, and finally the extent of the variation or maybe the dispersion from the mean value would be very low. But if you find that the cash flows are moving something like this, that first year it is 100, then it is going 200, then it's coming back to 100, then it is becoming 500, then it is becoming maybe say for example 800. So in this series of the cash flows, the element of dispersion is very high in both ways. The expected value for example was 100 in the first year and we have got first year, so it's fine. But the second year if expected value was 150 and we have got 200, though it is more by 50 units but dispersion has increased, and next year we were expecting 300 units of the sale but we have sold only 100 units in the market. So again the dispersion level or the variation level is very high. So we have not to do like this. So we can control the affairs of the project to some extent, and to minimize the level of variation or standard deviation in the cash flows, we will have to grow in such a manner. The sales of the projects we have to grow in such a manner that they move in a sequential manner, or maybe there is a steady growth. And if there is a steady growth, certainly the element of dispersion would be quite less, and the variation can be controlled. So if the cash flows become correlated and element of the variation is quite less, in that case we can say that the risk to a larger extent can be managed. But if it is not like that, and if the cash flows are highly uncorrelated and they are away from the expected values and as well as the mean value of the cash flows, in that case the element of risk would be very high, and the project may move into any direction. So it is with regard to the inflows. And similarly, when you talk about the outflows, we normally believe that in the conventional projects or in the traditional projects, outflows are only one time, that is in the zero or the construction period. So we have not to worry about the outflows. We know that how much is going to be the outflow or expense of the project. But as far as the inflows are concerned, they are maybe sometimes they are wildly varied, and because of the extent of variation, there can be high amount of the say standard deviation or the variation, and finally the cash flows can be uncorrelated and it can cause the high amount of the risk. So to manage the risk as per this model, you have to grow the sales of the project in a sequential or in a steady manner, so that the cash flows are largely correlated or perfectly correlated, and the element of the standard deviation is low, and hence the level of risk is also manageable. Now we talk about the next method, which is the very commonly used method, that is the simulation analysis. Simulation analysis, we all understand there's nothing new about the simulation analysis. We simulate the expected outcomes of the project. We create the project, maybe project in terms of the outflow and inflows as well as the NPV and IRRs. On the systems, on the computers these days, we follow the say simulation process. So it can be, earlier it was a manual simulation process. These days it's a computer based simulation process. So we can simulate the expected project or maybe investment proposal on the systems, on the computers, where we can take the model values, or you call it as the expected values of the cash outflows and cash inflows. All the variables we can take, that my level of the cash outflow would be certain. Say for example, I am going to make investment of the 1 million, right, and this is going to be the outflow, right, this is going to be the outflow, and then you can take the inflows, and for calculating the inflows you have to take the value of the sales, right, and then you have to take the value of the cost, and then you have to take the value of the taxes. So you can take these values on the presumption basis, and you can put these values, compare the outflows with the inflows being worked out on the basis of the sales, cost and the taxes. So finally you are arriving at the profit after tax. You are adding back into the say fixed cost, depreciation as well as the other fixed cost, and finally you are calculating the total inflows and then the net cash flow. And net cash flow would be the difference between the present value of the inflows and the present value of the outflows. So it's not maybe finally doing it in the practical sense, but on the systems, on the computers, you can run the simulation analysis, and you can create a dummy project on the systems, and on the basis of the say perceived values of the outflows and inflows, maybe that is for calculating the inflows, the sales, cost and taxes, and see the profit before tax, profit after tax we can calculate. And finally we can say that if all these things move like this, what is going to be the NPV of the project, and then we move the variables. While going for the simulation analysis, we move the variable, we sometime increase or decrease the investment, we change the say sales value, cost values, and the taxes values, and finally PAT, and then the say net cash flow values, and then we try to create another scenario. So simulation analysis means is a very commonly used analysis. So in this process, when you use the simulation analysis, you have to use a certain procedure, and this procedure is having the different steps. And first step involved is choose variables whose expected values will be replaced with the distribution. So the variables you have to choose. Variables means you have to take the cash outflows, cash inflow, means for calculating the cash inflow you have to take the sales value, you have to take the variable cost, you have to take the fixed cost, you have to take the taxes value, and then accordingly you have to calculate the profit after tax, the cash flow, and then the means operating cash flow, and then the while you subtracting the operating cash flow from the operating cash flow, when you subtract the from the operating cash inflow, when you subtract the cash outflow, so the net cash flow will be worked out. So you have to choose the variable, that is the first step, whose expected values will be replaced, right, with the distribution. Means over a period of time, means first you will take one distribution of the value of the variables. Variables are like your total cash outflow, and for calculating the cash inflow you have the sales level, you have the cost, variable cost, fixed cost. So first you will create one distribution of the values, then you will, for the second round of the simulation, you will change the values, you will then replace the old values with the new values, then you will create a new simulated scenario. So like that, first of all you have to choose the variables. Then second step involved is specify the value of the parameters and probability distribution of these variables, right. So what is the value of these parameters? That for example you are going to say that the sales are going to be 100 million, right. So if the sales are going to be 100 million, what is the probability of that? What is the probability of that? And for calculating, means you have to give the probability on the subjective terms. Sometimes you can give the probability on the objective terms also, but for example you say that the probability is for example say 0.7, right, or you call it as 70%. So how this 70% is calculated? This can be calculated both on the subjective as well as on the objective base. If you want to calculate on the basis of the objective base, then you have to have the past trend of this production and sales of not the present project but of the some existing projects but having the same level of the investment, same level of the revenue, same level of the cost and same level of the risk. If the comparable level of the project is available which is already existing in the market, so on the basis of their past performance you can assign the probability to the sales value, and that you can call it as that it is based upon some objective estimates. But if there is no objective estimate available and the project and the venture is coming up for the first time, in that case you will have to have the subjective estimates only by using the judgmental values and maybe by the experience of the people who are preparing the, say, who are doing the simulation analysis. So both the values you have to find out, the value of the parameter, for example the sales of 100 million and probability of happening of those sales of 100 million, for example it is 70% here. So that is the second step involved. Draw the values at random and calculate the NPV of the project. So on the basis of these values, you have to calculate the NPV of the project, and then you have to repeat this step 3, that you have to change the values of the variables and then you have to calculate a new NPV, and you have to create the different kind of scenarios under the simulation process, right? Finally, you have to maybe create the different scenarios and different simulated projects you have to create, right? And finally, means repeat the step 3 a number of times to get the large number of the simulated NPVs and plot the frequency distribution of the NPVs. So you can finally plot the, say, frequency distribution of NPV, and then you can say that, for example, how the trend goes. For example, the trend of this NPV goes like this. So it means one NPV is here, second NPV is here, another NPV is here. So you have to see here that though the NPV at this level is the highest, but then we have to see here that what was the risk associated to that, right? What is the probability of having this NPV? That would become that would be based upon the cash outflow, cash inflow, and cash inflow will be based upon the level of the sales, the cost of the production, variable as well as the fixed, and the taxes level and all that. So you have to see here that the level of the simulation or maybe the outcome of the simulation analysis, wherever we get the balanced output where the NPV is finally based upon the cash flow and the, say, the level of the risk, which is a manageable level, that would be our finally acceptable value. We have not to only go for the higher NPV. At this higher NPV level, we have to see the risk associated also, and finally we will have to evaluate all the results, right? We have to evaluate all the results, and on the basis of these results we have to finally take a call that which simulated scenario is going to give us the best results, and can we expect that this will actually happen in the ground? If it is actually going to happen in the ground, so it means we will implement that, and finally we will try to do what we have simulated on the systems or maybe on the paper, and finally we will try to convert that into the reality while maybe developing the project on the ground or that investment proposal on the ground. So simulation analysis helps us to, say, develop the dummy projects on the computers with the help of certain programs, and then to know in advance that if these are the, say, inputs given, and finally this is output available, expected output available from the project. So finally what is going to be the net result in terms of NPV or IRR. So you know in advance, before giving a practical shape to the project or to the venture, you know in advance that what is going to happen to the cash outflows, to the cash inflows, and for the cash inflow purpose, how the sales we are working out. So what is the, say, certainty of the expected level of the sales, cost and other things. So you can easily visualize in advance, and finally before giving a shape in the practical sense, you know the level of risk involved in the investment proposal, and you know how to manage it in advance before even practically giving shape to the project. So that way the simulation analysis works. It's a very good and interesting technique, but because it's complex technique, it's not very easy and everybody cannot do the simulation analysis. So use of the simulation analysis is not very high in the practical sense. Same is the case with the Hillier's model, and same is the case with the simulation analysis. So it's not very highly means applicable in the market. I'll show you the statistics also on the survey of the industry that to what extent these techniques are being used in the practical sense by the industry. So there we will find that largely the first 3 techniques are more in use. That is the sensitivity analysis and scenario analysis, and to some extent or maybe to some extent the break-even analysis. But these techniques are there, and for the sake of understanding or knowledge, you must be clear about that if we want to assess the risk of the standalone projects, what are the different ways available. So, after the Hiller's model, the fifth technique is the simulation analysis, and we can simulate the expected outcomes of the project prior to giving the practical shape to the project on the computers or maybe on the paper, and we can get to know in advance that how the project say outcome is going to be there, and how much level of the risk is associated, and how this risk can be managed. Now, here are some good things say spoken about the simulation analysis by the World Bank, because World Bank is always involved in the say funding of the different kind of the projects, and they are also of a very large value. They are sometimes at the government level or maybe at the corporate level also, but with the association of the government, and they are sometime in million and billions of dollars. So they also say speak very good about that simulation analysis is a very good technique. It's a very practical technique. So there they have cautioned about the one limitation of the simulation analysis, but largely World Bank has said that if you are able to make use of the simulation analysis, or if you have the resources and capabilities of simulating the projects before giving the shape it on the ground, so it would be very helpful to mitigate the risk. So they say that it may be instructive here to review the experience of the World Bank, that as we are going to know about it. And finally, they say here is that what the World Bank says is that simulation is a powerful technique. They call it as a powerful technique which permits the use of great deal of information which would otherwise be lost. So because you are creating the different simulated scenarios, so you are getting the best of the informations, and you are say moving the information from the expected level to the pessimistic level or to the optimistic level. So multiple simulated scenarios we are going to work out. So it's going to give us the very valuable information, very useful information, and that information is very practical information and going to help us to save the project from any kind of the risk, right? Second thing, they say that it is a highly efficient medium of communication, because when you communicate through the simulation to somebody, maybe they are investors, angel investors, or the venture funds, or maybe the financial institutions. When you communicate through the simulated analysis or simulated projects, maybe you have created a simulated project on paper or systems, and when you give a presentation of that simulation analysis to any external stakeholder who could be tomorrow internal stakeholder of the project, so they feel more convinced because it's very highly efficient medium. And we are going to show it to them that look, that on the basis of simulation analysis how the project outcome is going to be, and we can easily visualize that this project is going to be a valuable investment option. And the next thing is, it is not a technique which replaces the skilled judgment, right? They have said that it is not a technique which replaces the skilled judgment, right? On the contrary, it often requires the use of the more judgment, because how would you be calculating the value of the variables like sales or the probabilities, right? Because probabilities, as I told you, if some existing information is there, you can use the objectivity in assigning the probability. But if existing information is not available, if the comparable level of the project or investment option is not available in the market, so what judgment you would, means what way of deciding the probability you will use. So in that case, it's entirely subjective and largely based upon the judgment of the team of the experts who can visualize in advance that sales in the first year, though largely we are going to estimate on the basis of the market and demand analysis, but how far that market and demand analysis is true, that's going to be communicated by this expert's judgment, and accordingly the probabilities to be associated to those different kind of the variables. So last one important point, that is a point of caution. They say that despite the method's value or the method's best value, the treatment of the correlation between variables remains a major problem, right? It is clear that results can be completely misleading if correlations are not handled properly. The results can be completely misleading if the results are not handled properly. So what correlation they are talking about? And the correlation of variables means what kind of the correlations World Bank people are talking about? They are talking about the correlation among us, for example, when you have to work out the cash inflow, right? So for calculating the cash inflow, you have to have the different variables. On the top, you keep the value of sales, or we call it as the value of revenue. right? And then accordingly we are going to calculate the variable cost, then we are going to calculate the fixed cost, and then we are going to talk about the, say, the value of the taxes, right? And then we are going to talk about the PBT, and then we are going to calculate the PAT. So it means finally when you are going to assign the value of the sales or revenue, you are going to find out, and then you are going to link to this the variable cost, the fixed cost associated to the project. So there you have to find out that there has to be some correlation, that when you are changing the sales level from the one simulated scenario to the another simulated scenario, you have to change the variable cost accordingly, and you have to look at the fixed cost also, whether it changes at the different level of sales or not. So that correlation in the different simulated scenarios we have to maintain in these variables or amongst the variables. But if you are not able to change the expected requirements of these different variables, that when you are changing the level of sales, you have to change the level of the variable cost, maybe sometime in the same proportion, sometime in the different proportion. It may be possible that when you are going to increase the sales to a level which is beyond the normal level, so you can say my variable cost will also come down, because I am going to buy more material, more labor, more other inputs. So variable cost per unit is not going to remain the same as it is on the first 100 units. When I am going from 100 to 1000 units, my variable cost is also going to go down. But other way around, it may be possible that the fixed cost is not going to remain the same. Fixed cost is also going to change. So the whatever the level of the fixed cost at the 100 units is there, that's not going to be same at the 1000 units. It may be required that when you move the production from the 100 unit to 1000 units, your fixed cost also goes up. So you have to have the proper correlation. Number one, identification of the variables and assigning the probabilities, and then say establishing a proper correlation amongst these variables. If this correlation in the variables is not maintained properly, then the results can be significantly misleading, and the scenario, or we call it as the simulated results, which we call it as the best outcome, that may not be the best outcome, and that can create the problem tomorrow. So simulation analysis is the best technique, maybe one of the best techniques, but it requires more resources, more technical expertise, and very valid information on account of the variables. And finally, on the basis of that, we can calculate the final values. And finally, when we get the best simulated scenario, or maybe the best NPV out of this total analysis, then we are going to say that yes, now the project is going to be practically at this level. So we are going to have this much level of NPV or IRR, and this is after managing all kind of the risk. So it means we can take care of the risk also, and we can take care of the outcome of the project also. So it's a very good technique. So besides Hillier's models, next technique as we talked about is the simulation analysis. Now we will talk about the next technique, that is the third technique, or you call it as the sixth technique. In total it is a sixth technique, but lesser used techniques when you talk about it is the third technique, because the first three techniques are largely used. As I told you, people use sensitivity analysis, scenario analysis, and break even. They are widely used technique, and they are simple to use, quick to use, and we don't require a big amount of the expertise for the use of those techniques. But remaining these three techniques, maybe it's a Hiller's model or simulation, or maybe your decision tree analysis, these techniques require some next level of the expertise, resources, and technical capabilities also. So we are going to talk about now the sixth technique of the risk analysis of the projects, that is a decision tree. It's very interesting tool, it's very interesting technique. So we will learn this decision tree analysis in two ways. First, we will conceptually understand what the decision tree analysis is and how we develop a tree out of the different options, which we call it as the different decisions, and the chances of those decisions happening or becoming means practical. And then on the basis of those, that tree means which we are the tree which we are going to delineate, on the basis of that delineated tree we are going to evaluate the options or the outcomes, and finally we are going to say that whether the project is worthwhile, can we take up the project or we cannot take up the project. So first we will understand conceptually the decision tree analysis, and then we, with the help of a small example, we will try to understand that how the risk analysis can be taken care of by using this decision tree analysis. So this is the third technique, and or maybe in a way it is a sixth technique. Third is the least out of the means lesser used techniques. It is the third one. But if you talk about the total techniques of the risk analysis in the standalone project, so this is the sixth and the last technique. Very interesting, useful, and maybe the valuable technique. So, how the decision tree analysis works and how we can actually implement this for the risk analysis of the projects, that we will discuss in the next class. For the moment, we will stop here, and next class we will have a complete discussion about the decision tree conceptually as well as with the help of an example also. So, till then, thank you very much.